Hey, A-level physicists, what's the crack? So today we're going to look at the photoelectric effect, okay? So what it says here is I've got photoelectrons released when monochromatic light, and just a reminder, mono means one, chromatic is a color, so we've got a single wavelength of light, and it's hitting the surface of metal, okay? So just a reminder, if I've got the surface of metal, I've got light hitting that surface of the metal. If the energy of that light is greater than the work function of the metal, I will get electrons in the surface of the metal to be released, and then that's when they're called photoelectrons. Okay, and the equation on my data sheet for this is the energy of the light must equal the work function of the metal plus whatever kinetic energy that these electrons come out with. Okay, because when these electrons get emitted from the surface of the metal, they're going to have some speed that they're moving at, so that's why they've got kinetic energy. Okay. Okay, so what it says is, I know what the photon energy is. I know what the energy of the light coming in, and it's 4.2 times 10 to the negative 19 joules, okay? And that has to equal the work function plus the kinetic energy. So I'm already given the work function here, okay? But the units don't match. This one is in electron volts, and this one was in joules. So the first thing I need to do is convert my electron volts into my joules. And the way that you do that is that you look at the charge of the electron. So a charge of an electron is 1.6 times 10 to the negative 19. So to go from electron volts into joules, you just multiply through by that number. Okay. So what I have instead of work function now is I'm going to have 2.4 multiplied by 1.6 times 10 to the negative 19. Okay. Then I have to add my kinetic energy. Okay, and that's the whole point. We're trying to figure out what the maximum speed is. Okay, and I know anything that is moving, anything that has a speed, has kinetic energy. So this is the whole point of my question, trying to figure out what that number is. Okay, so again, because it says speed, I'm going to simplify this now because I know kinetic energy is a half mv squared. So I have is 4.2 times 10 to the negative 19 equals 2.4 times 1.6 times 10 to the negative 19. And again, we want to have speed in our equation now. So instead of writing kinetic energy, I'm going to write a half of mv squared. Okay. Because it's an electron, a photoelectron, I need to look at my data sheet to find the mass of electron. And the mass of electron is 9.11 times 10 to the negative 31. And then I have to multiply that by v squared. Okay, so what I'm trying to figure out is what v squared is. So to find v squared, I can just rearrange this math now. So to find v squared, I can take this over the magic bridge, so it becomes abstract. So what I have is 4.2 times 10 to the negative 19. Take away 2.4 multiplied by 1.6 times 10 to the negative 19. Then what I need to do is I can see that I need to divide through by this. So now I'm going to divide through by a half times 9.11 times 10 to the negative 31. When I do this math, that's v squared. So I just need to make sure to square root my answer at the end. And at the end, you should get a final speed of 2.8 times 10 to the power of 5 meters per second. So what we found here was what speed those electrons get emitted from the surface of the metal because the energy of the light was above the work function of that metal. So that's grand.